Now the next important concept is population proportion. So sometimes we don't use mean of our population for our statistical process and instead use population proportion. A population proportion is a fraction of the population that has a certain characteristic. For example, a poll of a particular candidate might show that she will get 40% votes. Or a company making products for car might be interested in the percentage of people who owns a car in a country. So all these are examples of population proportion. Now the next important question is, how do we get to know if it is a problem of population proportion and not mean? So the first condition is that the distribution is binomial distribution here. And secondly, there is no mean or average mentioned in the question. So that's how you can know if the problem given here is a population proportion problem or a problem of mean. Now let's see what are the formulas for population proportion. So let's say x is a random variable following binomial distribution. Here n is the number of trials or sample size and p is the probability of success. Then we have p hat is equal to x by n. Standard error is equal to square root p hat into 1 minus p hat divided by n. And z is equal to p hat minus p naught divided by standard error. So here x is the number of items you are interested in. Say in a product survey done on 100 people, 40 said yes to buy it. Then x will be equal to 40. P hat, Q hat are the estimate of population proportion P, Q, which are unknown. So P hat is equal to estimated proportion of success and Q hat is equal to estimated proportion of failure. And P naught is equal to hypothesized population proportion, which will be given in the question. So that is what population proportions are. Now let's move on to the next topic, that is central limit theorem. Now this is a very important or rather a central concept for a data science career. So let's see what the central limit theorem says. The central limit theorem states that the sampling distribution of the sample means approaches a normal distribution as the sample size gets larger, irrespective of the shape of the population distribution. So all this is saying is that as you take more samples, especially large ones, means greater than 30, your graph of the sample means will look more like a normal distribution. So as you can see in the graphs, as we are increasing the number of samples from n is equal to 1 to n is equal to 30, our graph is approaching a normal distribution. This means if we take larger samples and average the sample means from all the samples or average the standard deviation from all the samples, then it will be a representation of population mean or population standard deviation. So this is what central limit theorem states.